Section 4.3 covers exponential functions. So here's an example of an exponential function. I have f of x equals 2 to the x, so our x values are the power on 2. Friendly reminder that negative exponents are fractions, so here I have 2 to the negative 1, which is 1/2. Here I have 2 to the negative 2, which is 1/4, right? So our exponential function is going to look like this, rising from left to right. It's continuous. Its domain is all real numbers, and we're going to talk about that more as this section goes on. So an exponential function, as long as a is greater than 0, so a has to be positive, and a doesn't equal 1, because if a was 1, that'd be really boring, right? Because 1 squared is 1, 1 to the 4th is 1. It's not a very exciting, that becomes a linear equation actually. Then the exponential function is a function of the form f of x equals c times a to the x, where, like I said, a is greater than 0, a doesn't equal 0, and c isn't equal 0. And they're all real numbers. Our base a is called the growth factor, right? We're growing by a factor of that base. And because f of 0 equals c times a to the 0, remember any number to the 0 except 0 is 1, we have that c is called the initial value. Here are some characteristics of a graph of f of x. So the points -1, 1 over a are always on our graph. So 0, 1, and 1 comma a. Well, friendly reminder that a to the -1 is 1 over a to the 0, because that's our x power, would just give us 1, because any constant greater than 0 to the 0 power is 1, and a to the first power is just itself. If a is greater than 1, then it's an increasing function, right? It means it's going to look like it's increasing from left to right. If a is a fraction, then we're going to have a decreasing function. The x-axis is our horizontal asymptote. Our domain is -infinity to infinity, and our range is 0 to infinity, but 0 is not included. So let's go ahead and graph the following and state the domain and range. So if I have to plug in some x values, some good ones would be -1, 0, and 1. Let's do 2 as well, to give us our outputs. If I have 3 to the -1 minus 4, that's going to give me 1/3 minus 4, which is -3 and 3/4. Sorry, 2/3. -3 and 2/3. This is my graph, but remember that -4, that's going to shift my graph down 4. So now I have when x is 0, 3 to the 0 is 1, minus 4 gives me a -3. When x is 1, I have 3 to the first power minus 4, which is -1. And then I have 3 squared minus 4, which is 9 minus 4, which gives us 5. My graph has been shifted down 4, so this becomes our new horizontal asymptote. So here we have our horizontal asymptote we cannot cross. I have when x is -1, y is -3 and 2/3. When x is 0, y is -3. When x is 1, y is -1. And when x is 2, y is 5. So here's our exponential function. We have to keep all of those graphing rules in mind. Our domain is all real numbers. Our range has been shifted, right? We have to keep all those graphing rules in mind, like I said. So our range goes from -4 to infinity in this case. And this is an increasing function as it increases from left to right. Let's take a look at a decreasing function. So if I have f of x equals 1/2 x, this graph has no vertical or horizontal shift. So let's plug in some x values, and we'll see why it's decreasing. So if I have -1, that becomes 1/2 to the -1 power, which is 1 over 1/2, which would just give us 2. If I have 1/2 to the 0, well, any number to the 0 power is just 1. If I have 1 as my x value, I have 1/2 to the first power, which is 1/2. If If I have 2, I have 1/2 squared, which is 1/4. So this function decreases from left to right. If we go ahead and plot our points, our function's going to look like this. My domain is still negative infinity to positive infinity. And my range in this case is 0, not included, all the way to infinity. And this is an example of a decreasing function. Let's go ahead and practice solving some exponential functions. So if I have a to the u equals a to the v, then u equals v. What I need to do is I need to make sure that both of these, both sides of the equation are written in exponential form. So for example 1 here, I have 2 to the negative x equals 16, which is 2 to the 4th. So I have negative x equals 4. That means positive x is going to equal negative 4. If I have 3 to the 2x minus 5 equals 9, that means I have 3 to the 2x minus 5 equals 3 squared. This will give me, using our property, 2x minus 5 equals 2. I add 5 to both sides. 2x equals 7. So x equals 7/2. Let's go ahead and switch colors so we can see things a little more clearly. If I have e to the 2x equals e to the 5x plus 2, e isn't a rational number. We'll talk about it later on in this chapter. I have 2x equals 5x plus 2. Subtract 5x from both sides. That gives me a negative 3x equals 2. So x equals negative 2/3. Last but not least, I have e to the x squared equals e to the 3x times 1 over e to the negative 2. What we have to keep in mind here is that negative exponents are fractions. So I can rewrite this fraction as e to the negative 2. When I'm multiplying fractions, that means I go ahead and add their powers. So now I have e to x squared equals 3x minus 2. That gives me x squared equals 3x minus 2. I'm going to set this whole thing equal to 0 and factor. So I have x squared minus 3x plus 2 equals 0. The factors of 2 that add up to negative 3 are negative 1 and negative 2. So in this case, x equals 1 and x equals 2.